You know that feeling, right? When you're drowning in information about some complex topic and you just wish someone could, well, cut through it all, give you the essentials. That's what we're doing here. This is the deep dive, your shortcut to understanding. And today we're jumping headfirst into artificial intelligence, specifically AI and intelligent agents. We've got a pretty solid study guide here, definitions, quizzes, the works, and also a detailed lecture briefing. So lots to work with. Our mission really is to give you a clear, maybe even engaging handle on the core ideas. Cut through the jargon, focus on what actually matters. Think of us as your guides through this sometimes confusing landscape. And guiding us today, I'm really glad to have our expert here to help make sense of it all.
Hey, thanks for having me. It's a huge topic, but fascinating. Ready to dig in.
Great. So AI, it's everywhere, but pinning down what it is, tricky. Our sources definitely back that up. No single definition everyone agrees on, but they mention four main ways people think about it.
That's right. The study guide lays them out. First, there's thinking humanly. That's all about trying to model, how our own minds work. Cognition.
Okay. Mimicking human thought processes.
Then acting humanly. This is where the famous Turing test comes in.
Ah, the Turing test. Can a machine fool you into thinking it's human?
Exactly. It's about imitating human behavior convincingly.
So those first two are very human-centric. What about the others?
The other two shift focus. Thinking rationally is about logic, building systems that reason correctly, like using formal logic. And then the fourth one, which our sources really highlight, especially for business applications, is acting rationally.
Acting rationally. Okay, that sounds more about results. Doing the right thing.
Precisely. It's become really central. The working definition often used and mentioned in our materials is the study and design of intelligent agents, where an intelligent agent is a system that perceives its environment and takes actions that maximize its chances of success.
Maximize success. Okay, that makes a lot of sense, especially in business. It's about achieving the best outcome.
Exactly. It's less about how you think, human or not, and more about what you achieve. Are you making the best moves given the situation?
So this idea of an agent seems really fundamental then. What exactly is an agent in this AI world?
Yeah, it's the unifying concept.
Yeah.
The lecture notes give us the Russell and Norvig definition, which is pretty standard. Anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators.
Anything. That sounds incredibly broad.
It is, and that's the point. Think about it. A human is an agent. We sense with eyes, ears, touch.
Enact with our hands, voice, legs.
Right, but so is a robot with cameras and motors, or even a software bot, softbot scanning websites and clicking links. That's sensing and acting online.
Okay, software bots, robots, humans. Any other examples?
Well, a classic simple one is a thermostat.
A thermostat, how does that fit?
It senses the room temperature. That's its sensor input, its perception.
Yeah.
And it acts by turning the furnace or air conditioner on or off. That's its actuator. Simple, but it fits the definition.
Wow, okay. That really drives home how general the concept is. So it's this core loop. Sense the world, figure out what to do, and then do it.
That's the fundamental cycle. Perception, decision, action.
So what are the building blocks then? What makes up one of these agents?
The study guide breaks it down nicely. You've got the sensors, obviously. That's how it gets information in. Cameras, microphones, keyboards, thermometers. Depends on the agent.
Right. The inputs.
Then actuators. That's how it affects the world. Robotic arms, wheels, a screen displaying information, speakers.
But outputs the actions. Okay. What else?
Well, the input from a sensor at any given moment is called a percept. Just one piece of info. But agents usually need more context, right?
Yeah.
So they consider the percept sequence the entire history of what they've perceived up to that point.
Ah, so memory matters. It's not just reacting to the immediate instant.
Exactly. That history feeds into the decision-making. Now, abstractly, there's the agent function. This is like the perfect ideal mapping.
Yeah.
From any possible percept sequence to the action the agent should take. It's the theoretical ideal.
The perfect blueprint.
Right. But you can't usually implement that perfectly. So you have the agent program. That's the actual code, the real-world system running on some hardware that tries to implement that ideal function.
Got it. The function is the goal. The program is the attempt to reach it. So what makes an agent intelligent then, beyond just sensing and acting?
Good question. Our sources point to a few key characteristics. Top of the list is rationality.
Rationality. We touched on that with acting rationally. It's about making good choices.
Yes, but more specifically, it means acting to achieve the best expected outcome based on the percepts it has received and whatever built-in knowledge it possesses. It's all about maximizing that performance measure. We talk about the criteria for success.
Okay, best expected outcome. So it doesn't have to be perfect. It doesn't need to know everything.
Exactly. That's a crucial point. Rationality isn't omniscience. An agent can be perfectly rational but still fail if, say, something unexpected happens or its sensors miss something. It's about doing the best with what it knows and perceives.
Makes sense. You make the smartest play you can given the info you have. What influences how rational an agent can be?
The study guide lists 4 things. First, the performance measure itself. What defines success? Is it speed, accuracy, safety, profit?
Okay, you need to know what you're aiming for.
Second, the agent's prior knowledge of the environment. What does it already know about how the world works? Third, the actions the agent can actually perform. What are its capabilities? And fourth, that percept sequence again. What has it actually observed up to now? Rationality depends on all 4.
Got it. Performance measure, prior knowledge, available actions, and observation history. What else defines an intelligent agent besides being rational?
Autonomy is key. An agent should be able to operate on its own, learn from its own experiences, and not just rely on pre-programmed knowledge forever. It should adapt.
Learning and adapting on its own. Okay.
Then there's reactivity. It needs to perceive changes in its environment and respond to them in a timely manner. Can't just sit there if things change.
Makes sense. Needs to keep up.
And finally, proactiveness. Intelligent agents shouldn't just react. They should be goal-directed. They should take initiative to achieve their goals.
Ah, so not just passively waiting, but actively trying to get things done based on its objectives.
Exactly. Now, putting these ideas together, our sources describe a kind of progression in how agent designs or architectures have developed. They get more complex and capable.
Okay, let's walk through that. What's the most basic type?
That would be the simple reflex agent. These work purely on condition action rules, like if the car in front brakes, then start braking.
It's a direct stimulus response.
Pretty much. They look at the current percept and trigger an action based on a rule. They can work well if the environment is fully observable, if the current percept tells you everything you need to know.
But what if it doesn't? What if you need memory or context?
Right, that's their big limitation.
Yeah.
They struggle in partially observable environments. So the next step up is the model-based reflex agent.
Model-based, what does that mean?
It means the agent maintains some kind of internal model or state about how the world works. It uses this model, along with the current percept, to keep track of the parts of the world it can't see right now.
Ah, so it has an internal picture, like a little map in its head, based on past experiences and what it knows?
Sort of, yeah. It helps it handle situations where the current sensory input isn't enough. It understands, for example, that objects usually continue to exist even when out of sight.
Okay, that's definitely smarter. What comes next?
Goal-based agents. Now we're moving beyond just reacting based on the current state. These agents have explicit goals they want to achieve. They consider future consequences. If I do action A, then action B, will that get me closer to my goal? They might involve searching and planning.
So they're actually thinking ahead, planning sequences of actions.
Exactly. They're more flexible.
Mm-hmm.
But the study guide notes they don't necessarily find the best path, just a path to the goal.
Right. Gets the job done, maybe not efficiently. How do you get to making better, more optimal choices then?
That brings us to utility-based agents. These agents go beyond just having a goal. They have a utility function.
Utility function? Like how happy or satisfied the agent is?
Essentially, yes. It's a way of quantifying desirability. It assigns a numerical value utility to different states of the world. The agent then chooses actions that maximize its expected utility.
Expected utility. So it can handle uncertainty. Like if an action might lead to a really good outcome, but has some risk.
Precisely. It allows the agent to weigh the pros and cons of different outcomes, consider probabilities, and make rational trade-offs when goals conflict or the future is uncertain. It aims for the happiest expected outcome overall.
That sounds much more sophisticated. Is that the top tier?
Well, there's one more crucial aspect, learning agents.
Ah, right. You mentioned learning earlier with autonomy.
Exactly. Learning isn't really a separate architecture type in the same way. It's more a component that can be added to any of these other agents, model-based, goal-based, utility-based. A learning agent has a learning element that allows it to improve its performance over time by analyzing its experiences, getting feedback, and modifying its internal models, rules, or utility function.
So any of these agents can potentially get better with practice if they have a learning component.
That's the idea. It allows them to adapt to unknown environments and become more competent.
Okay, that progression makes a lot of sense. Now, stepping back a bit, our sources talk about the big overarching goals of AI. What are people ultimately trying to achieve?
The briefing document kind of splits this into two main tracks. The more near-term practical goal has been developing expert systems. This is AI focused on specific, narrow tasks.
Like AI for medical diagnosis or playing chess?
Exactly. Systems that capture expertise in a limited domain. This falls under the umbrella of narrow AI or weak AI. It's highly specialized.
Okay, specialized intelligence. What's the bigger, more ambitious goal?
That's the quest for strong AI, also known as artificial general intelligence, or AGI.
AGI, that's the one you hear about in science fiction a lot.
Right. This is the idea of creating AI with human-level cognitive abilities across a wide range of tasks. An AI that could, theoretically, do any intellectual task a human can.
But, and this seems important, our sources stress this is still hypothetical, right?
Absolutely crucial. Both the guide and the lecture notes are clear. Strong AI, or AGI, does not currently exist. All the AI we have today, impressive as it might be, is narrow AI.
Okay, let's just nail that down one more time because it's such a key distinction. Narrow versus strong.
Yeah. Narrow AI, or weak AI, designed for specific tasks. It might seem super intelligent at that task, but it can't generalize. Think Siri, recommendation engines, game-playing AI. It's what we actually have and use. Strong AI, or AGI. Hypothetical AI with human-like general intelligence adaptable to any intellectual task. Doesn't exist yet. It's the long-term, maybe far-off aspiration.
Got it. Narrow is real and specialized. Strong is general and hypothetical. So underneath all these agent types and goals, what are the fundamental pillars or building blocks that make AI possible?
Our sources mention several core concepts that are intertwined. There's intelligence itself, the overall capacity, then reasoning, processing information, drawing conclusions, learning, as we discussed, the ability to improve from experience. Machine learning is a huge part of this. Perception, making sense of sensory input from the world, and problem solving, finding ways to achieve goals or overcome obstacles. These aren't really separate boxes. They all work together to enable rational action.
Right, they're all connected aspects of creating something intelligent. Okay, this has been great for understanding the concepts. Can we maybe tie it back to some real-world things we use? Like what kind of agents are powering, say, Siri or Alexa?
Good idea. Well, based on what they do, you probably classify Siri or Alexa as pretty complex hybrid agents. They definitely need a model of the world, like knowing locations, contacts, maybe your preferences. They are goal-based, figuring out how to answer your question or fulfill your request. And they absolutely have a learning component. They get better at understanding your voice and anticipating your needs over time. Maybe even some utility-based elements for choosing the best answer sometimes.
So a mix of different approaches makes sense. What about Netflix recommendations?
That seems primarily utility-based and learning agent. The utility function is basically trying to maximize your viewing time or satisfaction. It learns your preferences, learning agent, and then uses that utility model to suggest things it predicts you'll value highly.
Trying to maximize my binge-worthiness utility. Okay, Gmail spam filters. Those lifesavers.
Those are likely model-based learning agents. They learn a model of what spam looks like based on features of millions of emails, learning, and they use that internal model to classify incoming mail, model-based.
Yeah.
They constantly update that model as spammers change tactics.
Constantly learning to stay ahead. And the really complex one, Tesla's autopilot.
Yeah, that's pushing the boundaries. It's definitely a highly complex hybrid agent operating in a very dynamic, partially observable environment. It needs a sophisticated model of the world around it from sensors. It's goal-based to navigate from A to B. It has to be utility-based to make decisions like lane changes, balancing safety, speed, comfort, legality.
Weighing lots of factors.
Exactly. And it's fundamentally a learning agent, constantly gathering data from the fleet to improve its driving capabilities. It likely uses aspects of all the advanced architectures we discussed.
It's amazing how these concepts layer together in real systems.
It really shows how the field builds complex capabilities from these foundational ideas.
This has been incredibly clarifying. So if you had to boil it down, what are the absolute must-remember takeaways for our listener from this deep dive?
I'd say three main things. First, the modern focus in AI, especially practical AI, is largely on rational agent systems designed to act optimally to achieve goals. Second, understanding the different agent architectures, reflex, model-based, goal-based, utility-based learning shows a clear progression in capability and helps you see how AI systems work internally. And third, always keep clear the distinction between narrow AI, which is powerful but specialized and exists today, and strong strong AI, or AGI, which is general human-level intelligence and remains a future goal. Getting those fundamentals gives you a solid base.
That's a great summary. Okay, so for you, our listener, as you think about all this, here's something to chew on. Consider a challenge or problem you face, maybe at work or home. Thinking about those agent architectures, simple reflex, model-based, goal-based, utility-based, maybe with learning what kind of AI agent do you think would be best suited to tackle that specific challenge? And maybe more importantly, what would its performance measure be? How would you concretely define success for that agent? It really makes you think about applying these ideas. Thank you so much for joining us today.
My pleasure. It was a great discussion.
We hope this deep dive into AI and intelligent agents has given you some valuable insights. Keep questioning, keep exploring, and we'll catch you on the next deep dive.